The topic we are discussing in this video is economical diameter for the pumping mains. So the economical word itself is having whenever we are choosing the pipes for the pumping supplies. So we have to choose it under some factors. Either it should be large, either it is of a small size. So in order to choose it properly, we have some method and we have some formulas. We will be considering all those things in order to consider a particular diameter as an economical diameter for the pumping mains. Let us check it how we are going to understand it. So when we compare in this simple diagram, on the y-axis we have shown annual cost, and on the x-axis we have shown the size of the pipe. So when we talk about the annual cost, as it increases, it comes to the lowest cost. So the lowest cost and the lowest cost which is caused by the size of the pipe is the economical diameter, we say it. The size of the pipe should be in such a way that it causes annual cost or the lowest cost to be invested. Let us check some of the points here. The diameter of the pipe can be reduced by increasing the flow velocity through the pipes. So the diameter, when as we know, area reduces, the flow velocity increases. But the increased velocity will lead to higher friction, head loss, and thus increased cost of pumping. So since area is reduced, velocity gets increased, but increased velocity always leads to the frictional losses, that leads to the frictional head loss, and it increases the cost of pumping because pump has to put more efforts in order to overcome the head loss. And hence, although the dia and the cost of the pipe can be reduced by choosing a higher flow velocity, the horsepower of the pump required will increase. When we go for choosing higher flow velocity, the capacity, that is the horsepower, that is we say it as a simple HP of the pump required, capacity of the pump required will increase, thus increasing the cost of pumping. For optimum conditions, we must choose such a diameter which together with pumping cost will make the total annual expenses minimum. So in order to make the expenses minimum and also the pumping cost minimum, we had to choose some particular diameter. That diameter we say it as the economical diameter of the pumping mains. The diameter which provides such optimum conditions is known as economical diameter of the pipe. So the empirical formula connecting the dia and the discharge, which is commonly used in the practice, is D is equal to, the capital D is for economical dia in terms of meters. It is equal to 0.97 to 1.22 root of Q. Q is for discharge to be pumped in Q max, meter cube per second. So this simple formula is used in order to calculate the economical diameter in terms of the meters. So next let us check how the head, power and also efficiency of the pumps is calculated. Under this, as we discussed when we were discussing the pumps, the total head H against which a pump has to be designed or pump has to work considers three of the factors. One is the suction lift or suction head, that we call it as HS. Next is the delivery head or HD, we call it as HD. And last is the head loss due to the friction, entrance and exit in the rising mains. The head loss we call it as HL. Sometimes we say it as HF also, since it is a frictional factor, but it creates a loss. The total head is sum of the suction head, delivery head and head loss due to the friction. Next, the work done by the pump in lifting Qmax of the water by the head H is calculated by the formula gamma W into Q into H, which is in terms of kilonewton meters per second, or else joules per second, or the watts. That formula is used in order to calculate the work done by the pump. So gamma W here, it is a unit weight of the water in kilonewton per meter cube, that is 9.81 kilonewton per meter cube, and Q is obviously the discharge to be pumped in meter cube per second. While calculating the water horsepower, that is WHP of the pump, it is then given by the formula gamma W Q into H divided by 0.735. This is a factor where 1 HP is equal to 1 HP is equal to 735, that is 735 watts, which is in turn equal to 0.735 kilowatts. So in order to get them in the HP, we will be using this conversion. Next, if efficiency of the pump set, then the brake horsepower of the pump, that is BHP, brake horsepower, is then given by the formula WHP divided by the efficiency. So WHP, we have the formula already, the same formula we have substituted here, and this one is the extra, that is efficiency, we have added. When we use this formula, we can easily get the BHP of the pump, that is brake horsepower of the pump. Lastly, head loss is calculated by the formula HF is equal to F dash LV square divided by 2GD. So in terms of the F is the frictional factor, it is dependent on particular type of the pipe which is used. L is for length of the pipe, V is the velocity, and G is for the gravitational factor, and D is the diameter of the pipe. So in this case, in the continuation of the formula, F dash is kept as it is, L is kept as it is. Instead of the V, we have substituted as Q by A. Area we know, since we are considering the square here, it is also coming in terms of the square. So area we know pi by 4 d square. So the same thing we have written it in elaborated form. These are the formulas that will be used to design the pump. Let us discuss on various pipe appurtenances that are used other than in the pipelines. So these are essential in order to be installed on the pipelines in order to have a good function of whole of the pipelines and the supplies. See, in order to drain the pipeline sections for tests, inspections, cleaning and repairs, and a number of appurtenances such as gates, valves, manholes, insulation joints, expansion joints, anchorages, etc., are provided at various suitable places along the pipelines. Among them, generally we will be aware of the valves, different types of valves that are used in order to operate, and also the manholes that will be provided in between the supply lines. These we will be familiar. Providing them is very much necessary. Sometimes they will help us in cleaning and repairs, and also sometimes for the inspections, and also for the effective function of whole of the system. These are must and necessary in order to be installed in the pipelines. First, let us understand the gates and valves that are provided in the pipelines. A large and different types of the valves are available. They are provided for proper functioning of the pipeline. Let us check different types of the valves. First of all, let us understand the profile of the pressure pipe showing locations of the gates and valves. So in this diagram, we can see this is an intake reservoir, and here is the distribution reservoir. Intake is the one which fetch the water and then it is supplied to the distribution reservoir, nothing but like overhead tanks. So in this case, this is a static head. When there is no flow, this is the line. So this is a hydraulic gradient line that we are considering for flow of the water. So here we can see how the pipeline is been moving. So under this, where we have provided the valves, see here in this side, so we have provided blow off or drain valve. See, we have provided here because of the shape, there may be a chances some amount of the water may get settled out there itself because of the difficulty in rising up. So in case of that, we have provided the drain off valve. See, in the top summit point, we call it as summit point, we have provided air valve, because whenever the pipe is like this, when water will be moving like this, there is a chance that air gets accumulated in the empty portion. In order to empty all the air that is present in that point, air valve will be provided. Similarly, again a blow off valve, underscore valve, again a air valve, and gate valve is one more. In order to control the flow of the water, gate valves are also provided. So this is about various points which will be used in order to provide various types of the valves. This is just to understand where the valves will be located, valves and gates. Next, let us understand the gate valve or the sluice valve. So gate valve or sluice valve are a very basic type of the valves that we use it in almost all the pipe connections. These are used to regulate the flow of the water through the pipes. See, whenever in a household scale, we know that whenever water will be coming to the supply, we say that valve is opened and valve is closed. This is a common word, we use it in the house scale. So that is to stop the water or to make it run, we will be using the sluice valve or a gate valve. In large pipelines, they are generally located along the pipeline at intervals of about 3 to 5 kilometers, and so has to divide the pipeline into different sections. Thus, during repairs, only one section can be cut off at a time by closing the gate at both the ends of the section. Here in this figure, we can see a simple structure of the gate valve. See, by operating the spindle, in order to operate the spindle, we have provided a wheel or a handle. By operation of the handle, the spindle can be moved up and down. In turn to the spindle, we have attached a wedge-shaped circular disc or a valve. This particular portion we call it as a circular disc or a valve. Just when it is operated up, the water will run in the pipe. When it is closed in its position, it will not allow any water to move further. So this is the simple structure how the gate valve or a sluice valve is provided. So in order to control the flow, this will be provided in a sections. For example, in whole of the supply to supply of the area to some of the roads, the beginning of the roads, these valves will be provided. If any repair is coming in any particular road, whole of the system will not be disturbed. By just closing the valve of that particular section, the repairs can be carried out. That is the intention. Let us check some more points related with this. The gate valves are usually placed at the summit points of the pressure conduits where pressure is low. They can be of cheaper or less stronger material. They can be of a cheaper and less stronger material only in cases whenever it is located in a summit points. Summit points are this kind of a points. At this point, providing gate valve or a sluice valve is easy and also economical. Why? Because water while rising up, it doesn't carry much of the pressure. Because of the low pressure, there is no much pressure that is exerted on the valve. So much of the pressure is coming on the valve, it cannot withstand such a pressures, and there may be a chances of its getting repaired. So, or it may come to a repair. So that is why we have to avoid its location in the other points, and we have to try to locate it on the summit point so that it works to be cheaper and less stronger material also, if can be installed on the summits, can be maintained. Next, the valve is made up of cast iron with brass, bronze or stainless steel mountings. So metallic items like cast iron, brass, bronze, these things will be used in order to make the complete material that is used for the valves. Valve consists of a wedge-shaped circular disc fitted closely in pressed against the opening in the valve, connected to a wheel by means of threaded spindle. On the road sections, easily we can see the hand wheel that is provided in order to supply the water. Generally, we can see the supply man who will be coming operating that wheel in order to release the water during the supply times. Generally, in the intermittent supply, that is a pattern of supply in which water is supplied only during particular hours of the day. In such a case, these valves will be very helpful, and these valves can be raised or lowered by rotating the wheel from the top either manually or mechanically. This is the condition with respect to the gate valve or sluice valve. Next, let us check the air valve. See, air valve are the special kind of the valves which are generally placed along the pipelines at the summits on both sides of the sluice valves and also on the downstream sides of all other sluice valves. See, on whenever we are providing the sluice valve on the downside, on a continuation of that, we will be providing the air valve also. Again, as we told in case of the sluice valve, this is also provided at the summit points. When placed on the summits, they ensure the safety of the pipe against the collapse. Similarly, when placed below the ordinary sluice valve, they will protect the pipe against the negative pressure which may be developed when during steady flow the valve is suddenly closed. So whenever water is rushing out, so we will be suddenly closing the valve. It creates some negative pressure on the valve. So that can be overcome by providing the air valve after providing the sluice valve. That is the use of the air valve. And such a valve automatically opens out as soon as the pressure in the pipes falls below a certain fixed value, thus allowing air to enter in the pipe. So here we can see the simple structure of the air valve. In this case, we can see this is the complete pipe section. Here it is provided some of the water, extra water can enter in this pipe. So counterweight is provided and this is the air inlet and outlet valve. So this is a circular or rectangular chamber and some float is also provided here. Water level in the chamber. So this keeps on maintaining. When negative pressure is coming, it makes water to enter into this portion. So taking off that negative pressure, after water level decreases and the pressure decreases, the water in the chamber comes down, and during this the air gets entered into the pipeline. So this is how the operation is carried out, and this works for the safety of the sluice valve also. Sometimes air gets automatically at high points when the supply is restored and the pipe is refilled after the repairs. The accumulated air obstruct the free flow of water and the pipe may get airlocked, and air relief valves are therefore required to be provided at all the summit points. As we told it in the early, so summit, during this kind of the summit points, when water flow is like this is a point where there is a chance of air getting accumulated at this point. See, if at this point air valve is provided, so it will take care of the extra air that is coming. By seeing the structure, we can understand when air is present in this flowing water, so that may obstruct the flow. So whenever air valve is provided, water enters in this way. Along with that, this is air inlet as well as outlet valve. Because of that, the extra air that is present gets released outside, making it free from the making free from the air or any kind of the obstructions that is created because of the presence of the air. So that is why this is suitable to be provided after the sluice valve or at the summit points. Next type of the valve we are considering is blow-off valves or drain valves or score valves. These three names are used to indicate the same type of the valves. See, these are provided in order to remove the entire water from within a pipe. Small gated offtakes are provided at low points. These valves are known as blow-off valves. These valves are necessary at low level points for completely emptying the pipe for inspection, repairs, etc. When opened, water comes out of these valves quickly under the gravity. They are made to discharge water into some natural drainage or a channel into a sump from which the water can be pumped out. And it may be, however, be stressed that there should be no direct connection between this valve and the sewer or the drain. So has to avoid the possibility of pollution of the traveling into the water pipeline, pollution traveling into the water pipeline. So this is a kind of the blow-off valve. These are generally provided at the low levels. Say low levels like this. So in these points, what happens is sometimes it is very difficult to drain off the entire water. However, due to the gravity, some amount of water remains in this point, lower points. In order, during repairing process, we have to completely empty the water. That is why at these points, blow-off valves can be provided. So that helps in case of the repairs also, and also helps in draining out the complete water when valve is opened. So this is a kind of the valve, we call it as a blow-off valve. Next we are considering the pressure relief valve. So this is, the name itself is indicating these are used in order to release the negative water hammer pressures that will be present in the pipelines. Water hammer pressures in pressure pipes can be reduced by using the pressure relief valves. This is the intention of providing this kind of the valves. Such a valve is adjusted to open out automatically as soon as the pressure in the pipe exceeds a certain fixed predetermined value. So when these are used on a pressure pipes are one wherever water is pumped. Because of the pumping activity, pressure in the water will be more. So in such a pipelines, providing the pressure relief valve is good. Whenever the pressure is excess, what happens is pipes cannot withstand. There may be a burst of the pipes. In order to overcome this problem, pressure relief valves can be provided so that all the pressure that is coming in excess of certain fixed value gets released through this valves. And due to this valve opening, certain water will get out of the pipe and thus reducing the pressure in the pipe. As soon as the water hammer pressure reduces and the pressure in the pipe falls up to the fixed value, the valve will close automatically, and such types of the valves are useful on small pipelines. Here in this figure, we can see the pressure relief valve in an open position. Here we can see there is a relief vent here, and this is a spring with adjustable setting. Next, this is a complete pressure conduit water flow direction, and after this we have denoted this Lewis gate after the pressure relief valve. See, here we can see whenever the pressure in the water is normal, it will be in the closed position. That is, this whatever the spring adjustment we have provided, this valve will be in a closed position. When the pressure in the water increases, it pushes up the spring with adjustable setting. Due to this, the water gets released out and it is taken out through the relief vent. When the pressure falls down, the valve also automatically falls down into the closed position. This is how the pressure relief valve is working. So by providing this, we can overcome the excess pressure that is present in case of the pressure conduits or the pipes. Next, we are checking out the check valves or reflex valves. Check valves are also sometimes called non-return valves because they prevent water to flow back in the opposite direction. Sometimes we have seen whenever the valves or the water flow is suddenly cut off, there may be a chances that water coming out in a reverse direction due to the sucking action or the negative vacuum that is created in the pipelines. So they can be overcome by providing the check valves or the reflex valves. They may be installed on a delivery side of the pumping set, so as to prevent the backflow of the stored or pumped water when the pump is stopped. This particularly happens in case of the pumping. In a house scale also this happens, and the reverse flow will be very common when pumps are suddenly switched off. Check valves are also installed on a pump discharges to reduce the water hammer forces on the pump. And such a valve may be simple, swing, check, or a ball devices in a small lines, but in large installations they should be designed to close slowly, usually with the discharge of some water through the bypass. So this is a simple structure of the check valve. This is a flap type. See, in this case, water can flow in this direction. When water is flowing in this direction, this swing automatically opens up and remains in this position. But whenever water tries to come out in this direction, this is made in such a way that it doesn't allow water to come up in the opposite direction. The water flow is allowed only in one direction. That is why these are called as check valves. Apart from studying the gates and valves that will be used in the pipelines, the next important appurtenances that is used in the pipelines is manholes. We will be generally aware of the manholes because whenever we will be walking on the roads, we will be seeing some manhole covers that is provided on the roads. Generally we are aware of in the manholes are generally provided in a cases wherever there is a junctions of the roads, wherever four roads are being meted, or else whenever there is a sudden change in the direction, or whenever there is a sudden change in the gradient, means from the upside to downside we have to change the pipe gradient. In such a cases we generally prefer to provide the manholes. And let us check some points related with this. These are provided at suitable intervals along the pipeline so as to help its laying and to serve for inspections and repairs. They are generally provided on a large pipelines bringing water from the source to the city at the intervals of about 300 to 600 meter, and so they are usually provided in case of the steel are steel, are hewn steel, are RCC pipes, and are less common on a cast iron pipes. So providing manholes through entire supply line is throughout the entire sewage line is most common, but for the water supply line we generally don't provide manholes normally to entire distribution pipelines. Generally it is provided whenever the large pipes are connecting each other, just like it is bringing the water from the river, then it is supplied to the treatment plant. In such a cases, in between we can provide the manhole, but there is no need to provide it inside the distribution pipelines. Why? Because there is no problem of the clogging in most of the cases, but as well in the wastewater there is a chances of the clogging and coming for the repairs. Manholes are most used in case of the sewage collection, but in case of the manholes they are rarely used, but once they are provided they helps us to serve the repairs and inspection, and also in other cases also it will be helpful. Next thing we are considering is insulation joints. Insulation joints are provided along the pipelines at suitable intervals so as to insulate the pipe against the flow of stray electric currents, and thus to check electrolysis. Rubber gaskets or rings can be provided as insulators in between the pipe lengths so as to prevent the flow of the electricity. See, insulation joints are provided in between by just providing the rubber gaskets or rubber rings in between the joints. Why? Because we know water is a good conductor of the electricity. So due to leakage of the electric current anywhere, it should not carry it up to the point we are supplying. That is why in between the supply lines, insulation joints are provided so that any electric current is flowing in the water pipeline has to just get dissipated there itself. That is why some rubber gaskets and rings are provided in between. Those joints we call it as insulation joints. Similarly, sometimes sufficient length of the pipe is covered with rubber covering so as to provide appreciable resistance to the flow of the current. This is the intention we are providing the insulation lines. Next is the anchorages. The pipes try to pull apart and get out of the alignment at bends and other points of unbalanced pressure. At such places, the forces exerted on the joints due to longitudinal shearing stresses caused by these unbalanced pressures are enormous, and the joints may get loosened, ultimately leading to the excessive leakage and failure of the pipes. In all such circumstances, in order to prevent the pipes from pulling apart, pipes are anchored by firmly embedding these points in massive blocks of concrete or masonry, which absorbs the side thrust, and the pipes must be well bonded to the anchors by angle irons and welded on to the pipes. Sometimes we have seen this, but we will be not aware of they are anchorages. See, these kind of two pipes are joining. There may be a chance there is a joint here, and due to the excessive stress that is coming out, these may move in opposite direction, leading to the leakages due to the excessive stresses that are coming, shearing stresses. In order to balance this, what generally we do is we provide anchorages. Anchorages is provided in terms of the complete concrete blocks, and also these joints will be welded off or riveted off into these blocks. Angle sections are also provided, so they will take care of these two pipes. Even any excessive shear stresses are coming, anchorages will take out that load and makes it free for the pipes to be in a position. These are